In this video, we're going to introduce you to the concept of pipe wall thickness. So let's have a closer look. Wall thickness is the term used to describe the measurement of how thick the metal is that a pipe is made from. There are actually three systems in which a pipe's wall thickness can be categorized. These are the weight system, the schedule system, and the fractional system. The weight system uses three categories to define the thickness of a pipe: standard, extra strong, and double extra strong. Limited in number, these three pipe thicknesses restrict a pipe designer's options. In fact, over time, pipe selection has increased in complexity. With the development of new chemical processes, the methods of manufacturing pipe have expanded to meet process requirements. Such a wide array of chemicals and fluids, with their ever-changing corrosive properties and their extreme range of temperature and pressure variations, has necessitated the manufacture of pipe in additional wall thicknesses. Now called schedules, these additional wall thicknesses allow a designer to specify a particular pipe that will meet the exact requirements needed for quality installation and safe operation. In this system, pipe, depending on the diameter, is manufactured in the following schedules. Now, don't worry right now if these numbers are not clear for you. We will come back to them later in more detail. The third system of categorizing wall thickness is the fractional system. This last system consists simply in measuring the thickness of a pipe in either a fractional or decimal value. Okay, at this stage, keep in mind, no matter which method is used to categorize a pipe's wall thickness, it will not affect the outside diameter. Why is that? Because the outside diameter is a set value that will not change. As a result, as wall thickness increases or decreases, it is the inside diameter that adjusts. An example of this variance in wall thickness is shown in the following figure. In this example, we are using the weight system. We have a 6-inch nominal pipe size, available in standard weight, extra strong, and double extra strong. Notice here that as we go from left to right, the wall thickness increases. Now, since the outside diameter for a given nominal pipe size is a constant, then as the wall thickness increases, it is the inside diameter that adjusts. And as you can see here, it decreases from left to right. Okay, now take a look at the following table. It represents carbon steel pipe wall thickness as a function of the nominal pipe size. As you can see here, for pipe 12-inch and smaller, the nominal size is not equal to the actual outside diameter. It is simply a convenient method to use when referring to a pipe. As a piping drafter or a piping engineer, you should be aware, however, that pipe 14 inches and larger is identified by its actual outside measurement. This extended version of the table shows typical pipe diameters and wall thicknesses using the weight system. Now, the formula that you can see here can be used to calculate the inside diameter of a pipe. Actually, the inside diameter is equal to the outside diameter minus 2 times the wall thickness. As an example, a 6-inch standard weight pipe will have a wall thickness of 0.280 and an outside diameter of 6.625. Now, substituting for the known values, we can then easily calculate the inside diameter. In our case, it is equal to the following. In this video, the concept of the schedule system will be introduced along with a concrete example. So let's have a closer look. First, recall the schedule system is one system among many others that are used to describe the measurement of how thick the metal is that a pipe is made from. As we have seen in a previous video, depending on the diameter, the pipe can be manufactured in the following schedules. So the question is, what is the meaning of these numbers? These numbers, called schedules, are in fact additional wall thicknesses that were developed in the piping industry to meet the requirement of new chemical processes. In other words, and to put it simply, for a given schedule and a given nominal pipe size, the corresponding wall thickness can be easily determined using the following chart. For example, a 6-inch Schedule 40 pipe will have a wall thickness of 0.280. Now, this chart covers only nominal pipe sizes from 6 to 20 inches and schedules from 10 to 60. We used this simplified version for the sake of demonstration. The following table is more complete and gives the overall picture for the pipe schedule system. It provides wall thicknesses, pipe sizes, and outside diameters expressed in both inches and millimeters. This table is also available in the downloadable resource section. Finally, don't forget that once you know the outside diameter and the wall thickness of a pipe, you can easily determine its inside diameter using the following formula. Recall, this was discussed in a previous video.